Hello, this is Mr. Stansbury. I'm going to take you through the 10C assignment. All right, so we'll start with number 1 here. Find the height of a flagpole which casts a shadow of 9.32 meters when the sun makes an angle of 63 degrees to the horizontal. So let's draw ourselves a picture here. All right, so there's our flagpole. Okay, casts a shadow of 9.32 meters, so 9.32 meters is the shadow that it's casting, so the sun is up here somewhere. Okay, the sun makes an angle of 63 degrees to the horizontal. Okay, so what you want to think of with this here is here's our here's like the end of the shadow casting there. This is a 90-degree angle here. So we want to think of that as this here would be 63 degrees. So this here is going to also be 63 degrees as well. Okay, so let's see if this is 63 degrees here. This is 9.32. We are looking to figure out how high this flagpole is, right? Find the height of the flagpole, so that's going to be our x. So from this angle, this is the opposite, this is the adjacent. So with SOHCAHTOA here, we've got opposite and adjacent. Opposite and adjacent is tangent. So we're going to want to do tangent of 63 equals opposite over 9.32. So to figure out what the opposite side is, excuse me, we're going to want to multiply both sides by 9.32, and then maybe instead of opposite, let's call this x. So that's gone. So on our calculator, we're going to want to do 9.32 tangent of 63 gives us 18.29. Doesn't specify where to round off to, so I'm just going to go 18.3. So we get 18.3 meters tall for our flagpole, right? Okay, moving on to the next one. Surveyor standing at A notices 2 posts B and C on the opposite side of the canal. 2 posts are 120 meters apart. If the angle of sight between the 2 posts is 37 degrees, how wide is the canal? So it's kind of nice because this one actually already draws it for us. So we just have to figure out what sides we're looking at. So from this angle, this is the opposite. We're trying to figure out how wide the canal is. That's the adjacent. So with our SOHCAHTOA, opposite and adjacent is dealing with tangent. So we would want to do tangent of 37 is going to equal opposite, which is 120 over adjacent, which is A. Okay, so since our variable's in the denominator, we're going to switch these 2 spots here. And just so you understand why we're switching those 2 spots, officially the long way is we would multiply both sides by A, right? And we have A tangent 37 equals 120. Divide by tangent 37 to get rid of the tangent 37. And we get A equals 120 over tangent 37. So what we do originally, we had tangent 37 equals 120 over A. I just noticed that here the 120 stays in the same spot, and then the tangent 37 and the A switch spots. So I just say, okay, I'm going to switch those 2. So you end up with A equals 120 over tangent 37, which is this here. Okay. So plug that into the calculator, and we get 120 divided by tangent of 37, and we get 159.245, so we'll go 159.2. So A equals 159.2 meters. So that means the canal is 159.2 meters wide. Okay. Moving on to number 5. Find the angle of elevation to the top of a 56-meter high building from point A, which is 113 meters from its base. What's the angle of depression from the top of the building to A? So find the angle of elevation to the top of a 56. So we're trying to find this right here, right? You're trying to find that angle of elevation to the top, okay? And then it also says what is the angle of depression from the top of the building to A. So they're saying what is that there, which is, if you'll hopefully notice, these two lines are parallel, this line and this line. So those two angles are going to be the exact same. So from this side here is the opposite from this angle, and this is the adjacent. All right. So with SOHCAHTOA, opposite and adjacent is tangent. So we would do tangent of theta equals, tangent theta is opposite, which is 56, over adjacent, which is 113. Okay, so we'll do, again, we're looking for an angle, so it's second tangent, and we do 56 divided by 113. And we get 26.36, so I'm going to go with 26.4. 26.4 degrees is this angle, which is also the angle of depression from the top of the building to A. They're both the same measure. All right, moving on to number 7. Sarah measures the angle of elevation to the top of a redwood in the Montgomery State Reserve at 23.6 degrees. So we've got some kind of big redwood tree here. Okay, and then let's say she's standing here, the angle of elevation to the top of this tree. I won't try to fake it, make it good. Angle of elevation is 23.6, so this is 23.6 degrees from a point which is 250 meters from its base, so this is 250 meters. Okay. Okay, so from 26.3 degrees, 250 meters from its base, her eye level, where the angle measurement was taken, is 1.5 meters above ground. So basically what they're saying is, like, here she is, and then really here's the ground right here, and they're saying that she is 1.5 meters above. So then this here is also going to have to be 1.5 meters above as well. Okay, assuming the ground to be horizontal, find the height of the tree. So what we really want to do is kind of ignore this 1.5 for now. We want to find the height of the tree, right? And then we can add on the 1.5 at the very end. So height of the tree from her eye level, 23.6. This side here is the adjacent. We're looking for the opposite. So, all right, so we've got our 23.6. We have opposite and adjacent. That's tangent. So we're going to want to do tangent of 23.6 degrees is going to equal opposite, which is x, over adjacent, which is 250. The number is in the denominator, so we multiply both sides by 250. Right, and those are gone, so we just end up having 250 tangent of 23.6. So we got 250 tangent 23.6. And that gives us 109.2 meters is how far it is from here up. Okay, this is 109.2, but now we got to add that 1.5 meters back on, so plus 1.5 meters for her eye height, right? And we are at 110.7 meters for the total height of the tree. Okay. Moving on, number 9. From a point A, 40 meters from the base of a building B. So let's say there's A. And here's our building that was not very well built because it's got some big wiggles in it, right? So anyway, you get the idea. Here's our building, doorknob. 40 meters from the base of the building, so here's 40 meters. The angle of elevation to the top of the building is 51 degrees. So angle of elevation, so that's from horizontal up, 51 degrees. And the and to the top of the flagpole D on top of the building is 56. So then you got to assume then there's a little flagpole here. And then they're saying that this angle, oh, that is just terrible. It's a little harder to see, but so then they're saying that this angle here is 56 degrees. Okay, find the height of the flagpole. So this is a little trickier because what you want to do is you want to find the height of just the building, right? And then you want to find the height of the building and the flagpole, and then subtract the height of the building from the building and the flagpole. So basically, here's what we've got. We've got the height of the flagpole is going to equal the height of the building plus the flagpole minus the height of the building. All right, so there's our high-tech formula right there. So let's find let's find the height of the building and the flagpole. So that's the one with 56 degrees. Let's do the building and the flagpole. We'll do that in red so that we can get this all figured out. Okay, so that's going to be the building. Let's see, we're looking for this here, which is going to be our x, and then this here is always going to be 40 regardless. So this is opposite, this is adjacent. So we're going to do opposite and adjacent is tangent. So we'll say tangent of 56, because that's this whole thing here, equals x over 40, right? So multiply both sides by 40. And we will figure that out. So we have 40 tangent 56 gives us 59.3. So the height of the building, 59.3. That's the building and the flagpole. So then just the building, we'll do that. Let's say we'll do the building in just green here. Okay, so the height of the building is going to be tangent of 51 equals x over 40. All right, so multiply both sides by 40, and we'll get x equals 40 times tangent of 56. So 40, not tangent of 56, sorry, tangent of 51. Right, that's better. So 40 tangent 51 gives us 49.4. So this is 49.4 meters. 49.4. This was 59.3. Right, so what we want to do is we want to subtract those two. So we take 59.3 minus 49.4, and we're going to get 9.9 meters. It should be the height of the flagpole. Okay? All right. Moving on to number 11. Find theta, which is the pitch of the roof. The pitch is considered to be how far up something goes versus how far out something goes. Okay? So the pitch of the roof, so we're going to want to, let's do this, let's make ourselves a right triangle, like that. If this whole thing from here to here is 15 meters, that means that this is 7.5 meters, right? But then you got an extra 0.6, so if we do 7.5 plus 0.6, we get 8.1 meters. So this from here out to here is actually going to be, draw an arrow in there, that's going to be 8.1 meters. This is 8.3, and we're trying to find the angle here. So from this angle, this is the hypotenuse. Hypotenuse. This is the adjacent here. So adjacent and hypotenuse is cosine. So let's do cosine of the angle is going to be adjacent, which is the 7.5, and the 0.6, which is 8.1, divided by the hypotenuse, which is 8.3. Okay? So on our calculator, we're looking for an angle. So second cosine of 8.1 divided by 8.3 gives us 12.60. So our angle there is going to be 12.6 degrees. Okay, that's going to be the pitch of the roof. All right, moving on to number 13. AC is a straight shoreline and B is a boat out at sea. So shoreline, B is a boat out at sea. So this is the shore. And this out here is the water. Okay, find the shortest distance from the boat to the shore if A and C are 5 kilometers apart. Okay, so this makes a right angle. This is 2 kilometers here. This is 47. Let's see, so that would make this what, 43, because 47 and 43 makes 90 degrees, right? Okay. And what we really want to know is we want to start knowing what's going on over here. Okay. Actually, here's something that they didn't put on here that's going to be very important for us. We know that A and C are 5 kilometers apart. So from here to here, oops, right there, is 5 kilometers. So if this is 2 kilometers, this has to be 3 kilometers. So now we have an angle, a side, and we can now find this other side. That's what we're looking for there, right? So from this angle, that side is the opposite. This side is the adjacent. So we're going to use tangent. Tangent of 47 equals opposite, which is 3, over adjacent, which is x. These two are going to swap spots. So we get x equals 3 divided by tangent 47 should be how far the the shortest distance from the boat to the shore. Okay, so let's calculate that out. 3 divided by tangent 47 gives us 2.797. So let's go with 2.80 kilometers. Okay. All right, so that's that one. Moving on to 15. Angle of depression from the top of a 150-meter high cliff to a boat at sea is 7 degrees. How much closer to the cliff must the boat move for the angle of depression to become 19? So here is our cliff. Here is the boat out at sea. I know what you're thinking right now. Wow, what an amazing artist Mr. Stansbury is. Yeah, I know. Okay, so angle of depression is going to be this here. So this is 7 degrees out to the boat, which means that this here is also 7 degrees here. Okay, the cliff here is 150 meters tall, and again, just kind of assume that that's a straight line. Should be a perfectly vertical line, but it's not. How much closer to the cliff must the boat move for the angle of depression to become 19? So then that means that the angle of depression is going to have to be 19. So that's where the boat's going to have to move to this spot here. Okay, so then we would say that this from here to here is then 19 degrees. Okay, so we got to figure out how. See, it says how much closer to the cliff must the boat move for the angle of depression to become 19. So what we want to figure out, we are looking for this distance right here. Okay, so let's do this. We know we can figure out what this whole distance here is, right? So let's do a small picture here. So we've got, here's our cliff. Here's our 7 degrees with our boat here. And we can figure out what this total distance is here, because this is 150. And then we also can figure out what this here, this is going to be, oops, this is also going to be 19 down here. Right, so this is going to be our 19 degrees here. This is still 150. Oops, 19 degrees. And then let's call that, say, Z. So if we end up taking this length here, so if we take Y and we subtract Z, that's going to give us, so this whole thing is Y. This part is Z, so if we take Y minus Z, that will give us the X that we're looking for. Okay, so let's find Y, and we'll find Z, and then we'll subtract those two to get X. Okay, so let's start with the Y. So this side here is opposite from angle 7. This is the adjacent. So tangent is opposite and adjacent. So let's do tangent of 7 degrees equals 150 over Y. So those two swap spots. So Y is going to be 150 over tangent 7. Right? So let's do 150 divided by tangent of 7 degrees gives us 1221.7. So 1221.7 meters is this total distance here. Let's write that down. So we got 1221.7. Let's figure out what this one here is. Okay, so that's going to be, again, this is still opposite, this is still adjacent. So we'll do tangent of 19 equals 150 over Z. So those two switch spots. Z is going to equal 150 over tangent of 19. Okay. So we'll do 150 divided by tangent 19. And that gives us that this distance here is 435.6. Okay, so there's our, this is 435.6. So we know that all we have to do to figure out what this X distance here is to subtract these two from each other. So we'll take 1221.7 minus 435.6. And that will tell us how far the boat needs to move, how much closer the boat needs to move to be at an angle of 19 degrees. So 1221.7 minus 435.6, and that gives us 786.1. So about 786 meters. That one takes a little bit more work to figure out, but those are good ones. Those that really kind of makes you think. So let's see, we got a couple more here. Let's try those. 17. An open right circular cone has a vertical angle measuring 40 and a base radius of 30. So if it's base radius, this here, the radius is 30 meters. All right. Find the height of the cone. So find out what this here is, h, right? So if this is a cone, this is going to be the same as this. So with this 40-degree angle just got cut in half. So this is now 20 degrees. That is a right angle. So if we're looking for the height, then what we need to do is see this angle. For this side over here is the opposite, and this is the adjacent. Right, so opposite and adjacent is tangent, so we'd want to do tangent 20 equals opposite, which is 30, over adjacent, which is h. Switch these two spots. H equals 30 divided by tan 20. Okay, so 30 divided by tangent of 20 gives us 82.4, and that's what, centimeters? So there's our height. So this thing here, let's see, let's put a different color, 82.4 centimeters is the height. Now B, find the capacity of the cone in liters. So volume equals 1/3 of pi times the radius, which we know is 30, so the radius squared, so 1/3 times pi times 30 squared times the height, which we now know is 82.4 centimeters. Okay, so all we're going to do here is just plug this in, and we'll figure out what the volume is. 1 divided by 3 times pi. You're going to want to use the pi button. This one here is my pi button, times 30 squared times 82.4. Okay, just double checking to make sure I got everything in right. Looks like I'm good. Push enter, and our volume is 77,660. 77,660, what is this, centimeters cubed. Okay. In liters, so that's cubic centimeters, which is, let's see, we need to know how many liters that is. Okay, this is something that's not mentioned in here. It would be helpful if they had it, but 1 liter is equal to 1,000 cubic centimeters. Okay, so to get from cubic centimeters back to liters, we'd have to move the decimal over 1, 2, 3. So that means we're going to take this decimal here, moving back 1, 2, 3 spots here. So the volume is going to equal 77.7, oops, not centimeters, but 77.7 liters if we round it to the nearest tenth. Okay? Okay, last one. Number 6. From the top of a cliff, 200 meters above sea level, so this is 200 meters. The angles of depression to two fishing boats are 6.7 and 8.2. So this would be 6.7, which makes this 6.7. And then the other one is 8.2. So from here down to here is 8.2, which makes this 8.2. And those are both degrees. Okay. How far apart are the boats? So this is similar to the boat question that we had. I don't remember what question it was, but it was a few that we did ago. So what we're trying to figure out is this here. How far apart are the two boats? So what we're going to want to do is we're going to want to take, just so we can show this visually. So this is our 6.7. So this is the boat that's farther away. So we're going to take, let's call this distance y. So that's from here to here. And if we take that distance and we subtract the distance from here to here, which will be, this is 200 still, oops. And then this is 8.2. These are right angles. Let's call that z. So if we take this whole distance y and subtract the z, we'll be left with x. So that will leave us with x. All right, so let's figure out this one, and then away we go. So this one here, here's our angle. This side here is the opposite. This side here is the adjacent. Right? So we'll want to do for this one here, tangent 6.7 degrees equals opposite, which is 200 over adjacent, which we're calling y on this one here. Variables in the denominator, so we switch those two. We get y equals 200 divided by tangent of 6.7. So let's figure that one out here. So 200 divided by tangent of 6.7. Oops, I got 20. So I got to insert another 0 and hit, oops, enter. And that gives us 1702.5, so let's call that 1703 meters. So that's this distance here. So this is 1703. Now let's go and find the distance from here to here. So that's going to be, sorry, this is opposite and adjacent still. So it's still going to be tangent of, this case is, instead of, oh, I did the, no, that's right, minus tangent of 8.2 is going to equal opposite, which is 200 over, in this case we called this z, so these two are going to switch spots. So we get z equals 200 divided by tangent of 8.2. Okay, so let's calculate that out. So we got 200 divided by tangent of 8.2 gives us 1387.9, so we'll call it 1388 meters. Okay, so this here is 1388. So then we just want to take those two distances and subtract them from each other, right? So we take 1703 minus 1388, and that's going to be our x, the distance between the two boats. Okay, so 1703 minus 1388, and we get 315 meters is the distance between those two. Okay? All right, that's all we have for the 10C assignment. If you have any other questions, please feel free to ask in class. Thanks.